Welcome back, wizards, to your lesson on Doppler effect. Do you remember what we spoke about in the previous lesson? We spoke about what Doppler effect is, which is monitoring the fluctuations or the changes in frequency to determine how far away or how close something is. It took into consideration the observer, and it took into consideration sound and light, and we did a calculation involving Doppler effect to see how that works in real life. However, there are multiple different applications for Doppler effect. Now, Doppler effect may be used in detecting submarines, detecting vehicles that are moving past the speed limit, and so much more. Have you ever wondered how you got caught in a speed trap? That's because as the vehicle is approaching you, the camera is able to decide or to calculate by using Doppler effect how fast you are actually going. Remember that if you pass the speed trap, then it would be unable to take a picture of your car and catch you. However, if it is able to do a calculation from a distance away, then it is able to decide at what speed you are traveling and then take a picture before you move past the trap. That's how Doppler effect works when looking at cars that are moving past the speed limit. Doppler effect is also used in arterial testing. In medicine, we need ways and methods in order for us to diagnose certain ailments, for example, blood flow issues. Using arterial testing and Doppler effect, we are able to match the flow of blood by monitoring the red blood cells and how they reflect in wavelength. By doing that, we can see if there is any constrictions or blockages within your arteries, and we can look at where the issue is and what is probably causing that. In order for us to reach that assumption or that diagnosis, we need to understand what is actually happening, and Doppler effects help us do that. It helps us identify the flow or the velocity of blood that is moving up and down. By doing that, we are then able to say that there is a blockage or a constriction, and we are able to treat that. Now, ultrasound is another example. Ultrasound, as you very well know, is mostly used in pregnancies. However, that is not the only use of ultrasound. It has many different uses. For example, ultrasound can be used in your liver, in your kidneys, in the ovaries and the uterus. So there are various different body parts in which ultrasound can be used to detect ailments in. Whenever someone hears ultrasound, they usually generally apply it to only pregnancy, and this is not true. So wizards, ultrasound uses high frequency sound waves. These high frequency sound waves capture live images that are inside of our bodies. So what that does is it takes the high frequency images, it collates the data, and then it gives you an image or a picture to look at, such as the ultrasound that we get. So Doppler effect using sound is able to detect the heartbeat of the fetus and then see how healthy that baby's heart is beating, or if there's anything that is harming or impairing the growth of the fetus. Now, ultrasound is also known as sonography. Now, what that means is that ultrasound can be taken as pictures or as a graph. So you can see how an ultrasound works in either 2D, which is your normal black and white, and there are some other types as well, but we'll go through that. So wizards, ask your mom and dad if they have a picture of your ultrasound, and then tell them you know how that ultrasound was captured. Now, using red blood cell frequency, we are also able to determine movement. So remember, we said that arterial testing uses the blood and the velocity of blood to determine blood flow in an individual. This works by using the red blood cell frequency to determine the movement of blood through your body's processes. Now, we also use that type of treatment in 3D ultrasounds. So if you can see the images that are on your screen, I hope you're not a sensitive viewer, because these babies, or us in general, don't look very good as fetuses. But the 3D image allows us to have a more clear image of what the baby actually looks like. Can you imagine if a mom and a dad were expecting a baby? Wouldn't they like to know what the baby looks like instead of staring at a black and white blob on a TV screen. So wizards, a 3D ultrasound is also using Doppler effect. So can we see that despite Doppler effect being a smaller section in physics, that is a large application in real life, whether it's in the medical field or in the engineering fields, Doppler effect is used throughout the world. Let's look at another example involving Doppler effect to see if we've learnt and gained the knowledge necessary for this section. So first, remember that we discussed that the source will emit waves, and those waves are crests and troughs, and we said we can represent them as crest, trough, crest, trough, crest, trough, crest, trough, crest, trough. And we said as it approaches the observer, they will get a higher frequency, so it would appear louder. As it moves away from the observer, this would appear to be softer. And what we speak about in regards to this is something called the pitch. And in order for us to look at the pitch, we look at the frequency. So those are just some terms that we look at when we speak about Doppler effect. So do you remember doing the previous example where we calculated the ambulance moving towards us and we calculated it moving away from us? We want to do something similar by looking at a different example. Remember that the formula that we would use to do this is our Doppler effect formula that we discussed, and we said that we assume speed of sound to be 340 meters per second. So when you have a calculation and it is not clearly specified what the speed of sound is, or if they changed the speed of sound, you will always assume 340 meters per second. You will also look at the observer and the source, and you want to see which is the moving object or variable. And remember that we put that as 0 when we're doing our calculation. Another thing to remember is how to assign the positives and the negatives. Remember that when it's moving towards you, you would use negative in the denominator or subtraction in the denominator because it should be getting louder. And if it's moving away from you, then you would use addition in the denominator because it would mean that it would be getting softer or lower in terms of frequency. So we can look at a different example. And in this example, it says, what is the frequency heard by a person that is driving 15 meters per second towards a factory whistle that is blowing at a frequency of 800 hertz? Assuming the speed of sound in air is 340 meters per second, complete this calculation. The first thing we need to see is what is asked of us. We need to decide what is going to be that whistle sound that we hear when we're moving towards it. So the person or the frequency that is heard by the person driving towards the factory. If I look at all the components that I have, I can clearly see that each of these are in their SI units. So there's no need for me to do any conversions. Now remember that before you attempt the calculation, any conversions that you want to make needs to be done beforehand. That will ensure that your answer is absolutely correct. The next thing you want to do is determine how to approach the question. Now remember that we have a formula, and that formula is F frequency of the observer is equal to frequency of the source, velocity plus or minus velocity of the observer over velocity plus or minus the velocity of the sound. Let's analyze this question. We know that velocity here, the two B's will be 340 because that is the speed of sound through air. But which is the stationary variable? Is it you who is driving at 15 meters per second? Or is it this whistle located on a factory that is fixed to the ground? That's right, wizards. It will be the whistle that is attached to the factory. So we can look at the velocity of the source as 0. Why would we look at it as 0? That is because that whistle will not move. It will not change its position. It is located on the factory. So if I were to complete this, and if I were to identify portions of the equation, I would say that the frequency that is the source is 800 because that is what it's emitting. Velocity, which is 340, plus velocity of the observer. How fast am I moving? I'm moving at 15 meters per second, all over 340. If it's moving towards me or away from me, I'm still going to add or subtract 0. Can we see that? Because that add or subtracting of 0 will not make a difference to my equation. Why? Because it doesn't matter if I'm moving away from it or I'm moving towards it. The velocity of the source is not going to change. So this is going to be put into my calculator. And when I do that, I'm going to get 835.29 hertz. So can you see how we've identified what the problem was? We identified that the source is not moving. The moving source or the mover is the listener, which is you as the person. You are moving towards the source. So you can take VL or VS, which is your velocity of the source, as positive 0. Because if the source is stationary, then it would still be equal to minus 0. So we can see how it's important for us to identify which is the stationary variable and which is the moving variable. Once we've done that, it makes our calculation much easier. And you can just say that my final answer, or at the bottom, you'll say that the driver hears a frequency of 835.29 hertz. And you've successfully done your Doppler effect equation. So guys, I hope that you went through that example and I hope that you understood every aspect of it. If you have not, please try to log on to our iWiz app where there are plenty of videos and lessons to help you and guide you through this process. You can also log on to the iWiz website for worksheets. They will help you really improve your knowledge on Doppler effect. So guys, log on to the website as well as the app for all the additional information that you need. Also remember that these information will also help you improve your knowledge in physics as a whole, especially the app since it has plenty of videos that you can use. Good luck, wizards!